German, right? German origin. Oh, right. Okay. Yeah, exactly. Yeah. Okay, ladies and gentlemen. Yeah, we would like to hear the lecture from Professor Lee. He will be talking about the importance of fishway to maintain aquatic biodiversity. Yeah, just to let everybody knows that our government now construct a lot of reservoir, yeah, for generating electricity. Oh, right. Okay. Yeah, for exactly, yeah. Irrigations, and then also for to maintain the what do you call that, floodings in Indonesia, and also for maintain the storage of water, especially for area in the eastern part of Indonesia. So that's why nowadays the government of Indonesia construct a lot of reservoir for that purposes. Yeah, in terms of aquatic biodiversity, we have also many migratory fish in Indonesia, like salmon fish in Western Europe or North America. But here in Indonesia, although we don't have salmon fish, but we have anguilla fish, what we call here in sidat. Yeah, this is the opposite migratory behavior of salmon. Salmons breed in upper stream area and then become adult in marine area, but anguilla fish breeding in deep sea, and then they go upstream to the river to be adult, and then again back to the ocean when they become mature to do some spawning. So if we dam the river that contain the migratory route of this fish, it will be a catastrophe for that fish. So that's why I think also nowadays the government become aware of conserving that fish, migratory fish in Indonesia. Yeah, so that's why perhaps Professor Lee Baumgartner already noticed that Indonesia now also increase the awareness of to conserve the aquatic biodiversity. So it is very important, very interesting for us. Oh, okay. Yeah, sometimes technical problem is coming. Right, okay, I don't want to talk too much. Yeah, I give the chance to Professor Lee, to Bumaya first, and then I sign off this welcoming remark. Yeah. Back to you, Bumaya. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Prof. Hefni. Baik, may I speak in bahasa Indonesia first ya. Sebelumnya saya ingin sampaikan bahwa Profesor Lee Baumgartner came from Institute for Land, Water and Society. That's right? Yeah. Oh yes, Gulbali Institute. Okay, in Charles Sturt University, New South Wales, Australia. Professor Lee is fish ecologist as general, but the research interest is about freshwater fisheries and ecology, fish passage and migration, mitigating human disturbance, fish and hydropower interactive, and riverine ecology. So this is the highlight about Professor Lee Baumgartner, and I would like to invite Prof. Lee to give a lecture. Please.
Hello, everyone. Thank you, Maya. Thank you, everyone, for attending today. We have the screen. I'll see if this works. This one is not working. Does this one here? We can wait and see, but thank you very much, everyone. Especially today, I learned today that we can't talk for too long today because tonight is a very important event. Indonesia is playing Thailand in the SEA Games final, as I hear. So we are hoping for a win for Indonesia football tonight. We're just waiting for the technical here, but I will say that the journey in Indonesia on this particular work started 2014 when I first met Pak Arif at the Mekong River Commission in Laos. And at that stage we had a workshop. It was a big international workshop to talk about the importance of fish and irrigation. And at that point Arif said, this is really interesting. We don't have such a program in Indonesia. And I remember we started with a really small grant, only $14,000 to start a little bit of collaboration. And then almost 10 years later, we now have a almost countrywide program in Indonesia. So Pak Arif, that's your inspiration and your work and your willingness to collaborate has really started all of this work. And it's great now to include some of the key universities in Indonesia as well and part of that work. We're having a very interesting journey. So thank you for all your hard work. Today I would like to talk, this is a general talk that I'd like to give to universities because we ask 4 main questions about why this is important. And it's great to see some students here today because when we work with fishery scientists and we work with engineers, we find that this isn't really part of the university curriculum, and it's certainly not something you learn is this working okay? Yeah, it's working okay. This is something you learn on the job, and this is something you learn by doing. And when I went through university in Australia, I didn't learn about fish ladders or fish migration. I was just interested in this, and this is something I learned about. So today I'll talk about some of the key learnings and the things that we can take into our careers, I guess, going forward on fish. Now I call this talk pushing fish uphill because this is about making sure fish can swim upstream. But I will also talk later in the talk that it's not just about upstream. And a lot of time when people think about a fish ladder, a ladder is going up. But we also need to think about the ecology of the fish and the importance of the fish also coming downstream. So hopefully today, if one of the things we can talk about is understanding the fish holistically and across their whole life. I can use the space. Yeah. The focus of the presentation today will talk about a lot about the fish that inhabit this Oceania region. So that includes Indonesia and Australia, but also many of the islands. Some fish we call inland fish, which can survive their whole time without getting to the ocean. But some of the big impacts of river infrastructure occur for fish which need to go between the freshwater and the sea. We'll talk about that today as well. And I always like to use this picture here just to highlight, I guess this is my research laboratory for most of my career has been working on the rivers of Australia. And we have 2 very distinct types of rivers in Australia. We have these coastal rivers which flow, they're quite short and they flow into the ocean. But we also have a network of inland rivers which are very long, thousands of kilometres long. And we have fish that complete their entire life in the freshwater parts of the river. And as we go through the presentation today, the lecture today, we'll make some distinctions about those 2 types of fish. But the first thing I want to touch on, and this is the very key point, and this is why we talk about river infrastructure, is that all fish have an importance and all fish migrate. Now, the migration may only be a few meters or a few kilometers, but it's a really important part of a fish's life cycle. Now, that's from the time when they are eggs right up to the time when they are adult fish, which are ready to spawn. In the Oceania region, there's hundreds of species of fish, many different diverse types, different body shapes, different swimming abilities, different spawning habits, different habitat requirements. And so one of the challenges of river restoration is to come up with solutions that can provide many different types of fish. And it's very difficult to do that because fish like this Murray cod, this is a Murray cod from Australia, which can grow to over 1 metre long, has different requirements to something like a rainbow fish, which only grows to a few centimetres. But if we're thinking about restoring migration pathways for fish, we have to think about the big fish and the small fish if you want to consider the entire fish community. And it doesn't matter where you are, if you're talking about eels that do coastal migrations. In New Zealand, we don't have huge diversity, but we also have a range of sizes. The same in Indonesia. So many different types of fish, over 1,280 species, if I remember Hak Arif's number. That's a lot of fish, a lot of different types of fish. And river infrastructure will impact all of them in a unique way. Interesting about Indonesia is that there are the 3 zones, and in each of the 3 zones are different types of fish. So in the Sahuland, we see fish which are more similar to that I'm accustomed to in Australia. But if we go to Sunderland, there's fish that are more familiar for the work we do in the Mekong. They're almost identical species of fish. And what we find is that when we think about the impacts of river development in each of those zones, the impacts are all fairly similar. It's just the way you implement the solutions which will change. So we will talk about the way river development impacts these fish shortly. The other thing that's important is that there's many parts of Southeast Asia, and this is true in Australia as well, where fish play a really important part of traditional culture. There's ceremonies, there's nutritional values, there's social values of fish. More recently, with people wanting to catch big fish, there's a recreational fishery, and this can generate financial benefits to people, but people like to go and catch fish, either for sport or to eat. And in Southeast Asia, particularly where we work in the Mekong, rice fish systems are very important. Fish provide protein, they provide micronutrients, they provide calcium, and particularly where we work in the Mekong, where there's some chicken and there's some pork and there's some beef, but fish are consumed almost 10 times as much as other sources of protein in the region. It's really important dietary. So whilst parts of Southeast Asia are growing rice, using food as a sustainability in Mekong, where we work in the Mekong, is really important because it can't be replaced by any other sources. So there's a real need to balance developing the land for irrigation and developing the land for fish, and making sure that they're both considered. Now, if we think about migration, there's lots of examples worldwide of animals that will migrate. Whether it's sharks and whales in the ocean, everyone thinks they migrate long distances. The monarch butterflies in North America, they migrate across countries to get to their breeding areas. And so if we think about big migrations of animals, people understand the concept of a migration quite well. Even today, when we went to the animalium, we learned about the flyways for birds. And we know that there are many species of birds that will fly across entire continents to complete different parts of their life stage. And so that's well accepted for birds. But people don't often make the same distinction for fish. And the concept of a migration pathway for animals or a flyway for birds, only just recently in the last few years have we started to use the term swimways as a way of describing what fish need to move. And this is no different to birds or other animals. Fish require swimways, and they require access to those pathways across their entire life. Whether it's a giant catfish swimming up the Mekong or an eel migrating to the ocean to spawn, it is critical that this happens. And so a lot of the work we do is making sure that when river development occurs, we do try not to interrupt the swimways for fish, because if we do, that's when we see fish declines. And here are some examples in sort of our region. There's a lot of fish, and these are the fish that we call catadromous. These are fish that will spend a lot of their time in the fresh water as an adult, but they will migrate to the ocean to breed. They have to have access to the salt water. If they don't get access to the salt water, they will not breed, and they can become extinct. Eels are a very famous type of catadromous fish because the eels spend almost 20, 30 years in fresh water. Then when they do their spawning migration, they go thousands of kilometres offshore into the ocean to spawn. And in many cases, the thinking is the juvenile glass eels go back to the same river that the parents came from. This is what we see happens with salmon in North America. We have coastal fish, which some fish like the grayling comes into the freshwater to spawn. That's what we call anadromy. And that's the same as salmon in North America. Salmon spend most of their adult life in the ocean and only return to the freshwater to spawn. And then they die. And then the juveniles do the same thing again. And there's a fourth category of fish called potamodromy, which is fish that complete their entire life in freshwater. They don't need to access salt water at all. And so if you block pathways or swimways for these fish within the freshwater sections, they can also become extinct. Now I talk about eels because eels are almost my favourite fish. I love the life cycle of the eel. It is so interesting to talk about eels because from the glass eel to the adult eel, they spend all their life in freshwater. Then from the egg to the larvae, they spend all of that time in salt water. The adults only go back into salt water long enough to get to the spawning ground, and then they will spawn and die. And then the larvae go back to the fresh water. Now this is critical. The eels, the majority of catadromous eels cannot spawn in fresh water. They need to access the salt water. And there's some really interesting data now which shows that these fish, when they go out into the ocean, they can migrate up to 4,000 kilometres from their river to the spawning ground, and they spawn 1 kilometre deep in the ocean on oceanic ridges. So it's really important that they have access. And it's really interesting as well that during the day, the eels will migrate at the surface, and at night they go down deep. And so not only do they travel long distances, they also have very complex behaviour on the way to the spawning grounds. This is an example here of eels which were tracked from southern Australia to their spawning grounds. Some of them swam as far as New Caledonia from southern Australia, and they tracked these fish with satellite tags. So they installed a satellite tag onto the eel. Now when the eel started migrating, it recorded all of the data, how fast the eel was moving, how deep the eel was. At the end, the satellite tag pops off the fish and floats to the surface. Then it transmits all of its data to a satellite, and that then gets beamed back to the scientist. So they were able to reconstruct the spawning migrations of these fish, and it's a lot more complex than we previously thought. And it's very similar for Indonesian eels. All of the Indonesian eels, and this is a particular example from Sulawesi Island, are heading into the North Pacific region at different scales for spawning. If they don't complete that migration, they will not lay their eggs and they will not have larvae return to the rivers. And we'll talk a little later on about why that is so important. But because, eels are just so interesting for me because so many people worldwide eat eels. They're a very important part of people's diets. In Indonesia, they fetch a very high price in the export market, as high as $5,000 per kilo for the glass eels when they return to the river. So it's really important economically. But ecologically, they're so cool. They are so interesting and so, they're just my favourite fish. I'll talk about eels all day. So I hope that reinforces that for the majority of fish, migration is critical and they have to move. When we develop our rivers, now developing the rivers is quite essential for humans, and I have to make that point. Dams to create water supplies, dams to create hydropower. diversion weirs for irrigation. It's all creates a critical service to humans, but it can impact fish. And these are some examples of structures which impact fish. These can be as small as a very small road crossing. In Australia, a crossing that's 25 centimetres high can block fish. That's only that high. That can interrupt the migration of fish. So it doesn't actually need to be a big dam. Most people understand that dams will block fish migrations. If you can see this particular dam here, now that is a blockage for upstream migration, obviously. But because there is no flow coming over the top of the dam, it's a blockage for downstream migration, because any fish which are swimming from upstream to downstream have no way to swim through that dam. So dams, it's important to understand, block fish in two directions. This is a map here of all of the big dams that have been constructed worldwide since 1880. Now these are dams which are over 15 metres high. These are big structures. There's some hot spots around North America, in Brazil. Europe has been very extensively developed, and some dams have started to be constructed across Southeast Asia. But if we look at the dams that are scheduled to be built, these are ones that are planned or either under construction. There's not so many more being built in America. In fact, America is now removing dams. Australia has dammed all of the rivers that can be dammed. There's a lot of dams that are still being built in India and in Southeast Asia. But we're almost approaching the point where we can't fit any more dams on our rivers. They're almost all dammed. And some of our dams are approaching the end of their effective life and are being considered for either replacement or removal. And so there's a point coming very soon, globally, where we'll have to make some decisions. Do we replace our dams? Do we make them bigger? Do we make them smaller? Or are there other ways that we can store water that get the same outcome? And this will be happening over the next 10 to 20 years. Now, they were only big dams. A lot of the work we have done involves smaller dams. So these are dams, these were what we call weirs, which may only be up to 6 metres high. Now, a lot more of those get built than large dams. And they're almost, you can see here, this is our Australian map of the Murray-Darling Basin. These are all weirs which are less than 6 metres high. You can almost join the dots to see the flow of the rivers. Just in that catchment alone is over 14,000. And every single one of those blocks the movement of fish. And this is the Mekong. And you can see the Mekong has been very well developed as well. There's over 30,000 smaller head barriers in the Mekong. Not so many dams. We did a map of this. This is all weir or water regulating structures which are less than 6 metres high, excluding road crossings and bridges. If we include road crossings and bridges, the number is over 1 million. So there's really big interruptions of fish movements. And these are what we call barriers to migration. Now, but barriers don't always need to be physical. We always think of a dam and the fish swims to the dam and can't get past. We can also have what we call behavioural barriers, which are things that alter the behaviour of fish and stop their migration. And a really classic example of this is what we call thermal pollution or thermal effects of reservoirs. This is where we get a reservoir which is heated at the surface and the water becomes warm, and the deep water can stay cold. Now, quite often at many dams, the water is released from the bottom of the dam, and so we quite often see the surface of the reservoir is warm, but the water immediately downstream is cooler. And that can create a barrier to fish. If the water is colder than the fish can tolerate, they will swim away. And so this is what we call a behavioural barrier. This is an example here. This is an outfall of it doesn't need to be a weir. This is an outfall of a power plant which uses seawater to cool the turbines. The water can become incredibly heated around these power plants, And that creates a it's like this own thermal environment around the dams. This can actually impact any fish in that region which are cold water fish will swim away from that. Bridges can affect fish. Now, I'm not sure if you can see it clearly there, but under this bridge is a whole school of fish that's sitting in the shade. Some fish like shade, some fish don't like shade. We did some work in Australia where we looked at the migration rates of fish in the middle of the day in an area which has no light, which was shaded, versus an area which had full daylight. There were some species of fish, when we reduced the intensity of light, that stopped migrating because they didn't like the darkness. So light can be a behavioural barrier to fish migration. And in some areas now, we are building bridges which avoid shadows so that fish can continue to migrate. This is a common one as well, areas where rivers have low oxygen. Obviously, fish can't survive in low oxygen. They will swim away from this area, or sometimes they will die. This is what we call hypoxia. This creates a very big, significant barrier to fish. They won't swim in that area and they will actively avoid it. And the final one is chemicals. Quite often where chemicals are discharged into rivers, and you can see here some of these areas here where different chemicals are discharged by factories, fish will actively avoid those areas as well. So when we think about barriers to fish migration, we quite often now think about both physical barriers and behavioural barriers, because they both have the same effect of blocking the fish's life cycle. And this is what we see. This is a graph of Murray cod fishery in Australia. The first dams were constructed in the Murray-Darling Basin around about 1940. And it didn't take long after dam construction and altering of the flows for the numbers of fish to drop very, very significantly. And in 1998, we actually closed the commercial fishery because it was no longer viable. Similar in the USA, this is the decline of salmon in the Columbia River. Hydropower dams were starting to be built in the Columbia River from about 1900 to 1950. And because salmon have to get from the ocean to the spawning grounds, they declined very rapidly. And there was a very famous paper which was written by John Williams, which stated that at the moment, the salmon, there's fish ladders built for salmon and there's stocking efforts to bring the salmon back to the rivers. They said if they stopped the artificial stocking of salmon in the Columbia River, they would all become extinct within 5 years. So even though some methods have been taken to arrest the declines, it is still a really bad situation. And closer to home, so this is a map of the, this is a graph of the glass eel catch in the Sukabumi district. Only 10 years ago, the harvest of glass eels was really high. And since the rivers have been developed in the area, we've seen big declines. Now, this is primarily because the eels have to get to the ocean to spawn, and they have to move back to the freshwater to survive in adults. Of all of the fish that are really sensitive to the barriers, eels are probably one of the most important. And we're already starting to see this in many parts of Indonesia. The glass eel returns are dropping, and the adults which are spawning out in the ocean are dropping. And this is one of the impacts of hydropower on eels. Because eels are a very long fish, they are long, sometimes up over 1 metre long. Sometimes the only way they can go downstream, particularly where there is a gate or a hydropower plant, is through the turbine or under the gate. Now, because the eel is so long and the turbine is spinning, they cannot swim through the turbine fast enough. And we see this very commonly, is that eels are chopped by the turbines as they swim downstream. And it's not a very sustainable situation because those fish are the spawning fish. They're going out to spawn. And if those fish don't get to the ocean to spawn, there's no larvae coming back. There's no glass eels coming back. So in areas where there are hydropower plants being built, we are doing a lot of work now, particularly on Sulawesi Island, to improve the downstream passage of the spawning eels to make sure that they can return. So what can we do about all this? That's all very bad news. But there is some good news, and this is where the work that we are doing with Bumaya's team and with Pak Arif's team is starting to help. So this is one particular solution that we've been working on, but it's part of a range of different solutions. So we've been building fish ladders. And a fish ladder is basically a channel which has water which flows at the pace that fish can swim against, past the dam or a weir. It's basically a way of reinstating a passageway for fish so that they can get past barriers. This is the life cycle of a fish in Australia called a golden perch. Now, this particular fish can migrate up to 3,000 kilometres. It only survives in fresh water. But what we've been learning is that these fish will migrate upstream to spawn. They will lay their eggs, and their eggs have an oil droplet, so the eggs float. And the eggs can float downstream 60 to 80 kilometres is what's been estimated. They then hatch into larvae that continue to drift downstream. So this is what we call egg and larval drift. The flow is taking them downstream. Then they finally grow to juveniles, which can swim against the current. Then the fish really strongly swim upstream to offset that downstream drift, and they settle into different habitats. So historically, when we thought about the migration for fish, we only thought about the adults. We only built a fish ladder or a swimway for those adults. We now know that we have to let the adults get up and spawn. We then have to make sure that the eggs and the larvae can safely go downstream to complete that life cycle. So it was a really interesting turning point for us, was that just thinking about adults is not enough. So we have a range of different fish ladders when we have different species of fish. This one here is what we call a nature-like fishway or a rock ramp. We build this out of rocks, and the aim of this fish ladder is to be like a river, be like a rocky river. It looks similar. So once we understand the swimming ability of fish, we can build a rock ramp fishway, and the fish will swim up past the barrier. This one is a vertical slot fishway. This one's made out of concrete, but it's a similar principle. We have a flow through these, what we call cells, and the fish swim upstream and continue their migration. We're actually building one of these on the Chiboreno River near Sugabumi, currently working with the Water Resources Department on this. This one was developed in Belgium in 1900, called a Denil fishway. It's really suitable for large fish that swim near the bottom. But effectively, what a fish ladder does, and these are the essential components of a fish ladder, we have this approach section here where fish are swimming towards the weir or the dam. They then find what we call the entrance to the fish ladder. They then swim through the fish ladder and upstream to continue their migration. Then the fish that come downstream do the same thing. They will swim from upstream to downstream. They will either go through the fish ladder, over the spillway, or if it's a hydropower dam, through the turbines. And so we have to consider how best we get fish upstream, and also how best we can safely bring the fish downstream. Now, there are some examples in Indonesia, but not too many. Not too many. This one is a fish ladder which was built in Sumatra on Perjaya Dam, which is near Madapura. The fish ladder we can see here, and I have a video which shows how this works shortly. But this fish ladder, there was a few problems with this fish ladder. It was built 35 years ago. It was built by a Japanese engineering company which used the designs for a Japanese fish. They didn't consider the local fish in the design. And so we found that it's not so good for Indonesian fish, because the Japanese fish, the ayu fish, which is a really important migratory fish in Japan, can jump 3 meters high by itself. It can just jump really high. So the Japanese fish which jump and swim really strong don't live in this river. This is the Komering River. And so using that design in the Indonesian river hasn't been particularly successful. And Mas Dwi has almost completed his PhD at this site to look at the ways that this can be improved. But the idea was right, because the fact that this was considered for a fish ladder was a good thing. And the fact that we have learnt now how better to build it is a good thing as well. This is what the site looks like here. So the fish swim from upstream. They swim across here to the fish ladder, through the fish ladder, and then upstream to continue their migration. That's the general principle of that. And if this will work, if I can hit play. Oh, is it working? Ooh, something's happening. I think I just broke the internet. Sorry. I can go up to the slide again. We might have to start the video from the... Everyone would think that we've been doing Zoom now for 4 years. Zoom should be much better than it is. Okay. Can we? Here we go. I'll go back to that slide and we might hit play from the camera. Oh, too far. Okay. If we can play. There we go. Thank you. Go again. Here we go. So this is the fish ladder at Pajau Dam. It has what we call an orifice that the fish can swim through. And it also has a notch at the top that the surface fish can swim through. So the fish ladder has actually been designed for bottom fish and for surface fish. It's not working very well, is it? No. Yeah, maybe we can move on. The fish ladder itself, so the fish are swimming along the bottom and along the top. So it does provide some passage for some fish, but we're learning from this experience, and the fish ladder that we are building at the Cibareno River will incorporate all of the learnings from this and be completely designed for the Indonesian fish. These are some examples here from Lau PDR. These are some what we call barriers. These are floodgate barriers, which when we turned up at the site, we knew that these were not very good for fish. And these were funded by the World Bank, and the World Bank invested in making these more fish friendly. And so you can see here, these are the before figures, and this is what they look like now. So we took the information from the local fish and we translated that into a suitable design, and these structures can now pass fish during the rainy season. So all of a sudden we have rehabilitated the fish passage at these sites. And what we are trying to do now, and if I go back to my example of the golden perch, is that we are trying to reconnect this at a landscape scale. So all of the examples I've showed you so far are at one site. But what if the fish migrates thousands of kilometres? So this is the golden perch I talked about earlier. When it migrates, it doesn't just migrate at one site, it migrates up entire river systems. So when we think about reconnecting the swimways for the golden perch, we have to think about all of these dots which represent barriers to their migration along their pathway. And in 2001, we started a project in Australia, which was to build a fish ladder at every single one of those barriers and rehabilitate the entire migratory pathway for those fish. And it was finished in, I think it was about 2015. And that was the first time in almost 100 years that the golden perch could do a migration across its entire spawning range. So they can be very successful when they are built correctly. Now, the fourth point I'd like to talk about is, at this point, we were only talking about migration, and sometimes just thinking about the migration is not quite enough to recover the fish. Because in rice fish systems, fish don't only move in the main channel, they also interact with the floodplain, especially in the rainy season. And sometimes that's really important for fish to access nursery habitats, because the floodplains are very productive areas. So not only do we have to think about fish moving up and downstream, we also have to think about fish moving laterally or sideways, so that they can access these habitats on the floodplain. So when we think about rehabilitating fisheries, especially when we think about river development, yes, fish ladders form one part of the tools, but there's also a suite of other, what we call interventions, which are needed. We may need to control overharvest of fish upstream. We may need to improve habitat. We may need to, where there's cage aquaculture, make sure that's sustainable and doesn't affect water quality. We may actually want to reinstate habitat to create better outcomes for fish. And this is what that looks like in a rice fish system. We might have fish ladders allowing fish to get upstream. We might have fish-friendly gates allowing fish to move into irrigation channels and survive on the floodplains. We may have controlled fishing or community refuges in floodplains where the juvenile fish can survive and grow. And so integrating this at the landscape is really important. And one of the reasons we're here this week is because we've prepared a catchment blueprint for the Coomering River, which talks about how we can integrate all of these solutions to protect fisheries at the landscape scale. So that may include putting habitat back in the river, screening points, because one thing we know now is that when you divert water for irrigation, you also divert the fish and take them away from the river. So you can actually build screens that protect the fish. Environmental flows from dams to create spawning for fish. Bypasses, more stocking of fish, or even taking away alien species. And when you integrate all of those measures at the catchment scale with technical solutions, that's when you start to get healthy rivers and start to get good outcomes for fish. And so a lot of the work we are doing is now moving from the fish ladders into integrating some of these sustainable landscape scale interventions to protect fish. And so just to conclude, and thank you all so much for your attention today. The 4 key points to take away from this lecture were that all freshwater fish are migratory. River development can impact the migrations. We can implement solutions to reinstate the migratory pathways for fish, but it is really important that we think about the whole catchment when we're implementing solutions so that we can rehabilitate the whole life cycles for fish. And I would just like to acknowledge all of the people that has facilitated this work. It's been a really good team effort from many people over many years, and we look forward to continuing this work. So Subramaya, I hope that was okay. I hope that was the type of topics you were after, and I'll thank you everyone for your attention today. Thank you.
So interesting. Thank you very much. Is that okay if we open for question and answer? Yeah,
sure.
Okay. So I would invite, I think from this room first, and then I will go to the Zoom room. Please, Bapak, Ibu. Oh, okay. Okay, Irfan, please.
Well, thank you for having me. I'd like to say thank you also for the presenter. It is such an interesting presentations. And this I would like to ask because, yeah, we all know that Indonesia has mega biodiversities, also that freshwater fish. And sometimes if we think about the fish ladder or fishway, we face something regarding of social, economics, and cultural aspect that could be a problem, that could be a search of the problem. So how about in Australia? Because we don't know. In every country has a specific things that could be a problem, you know. And also, that's my first question. Can you describe what the Australia challenges and how to build the fish ladder there? The second question is, sometimes our government build the water buildings such as reservoir or dam that is less than 3 years, or our government wants it to be faster to build the dam or construct the dam. And they want us as the academics to assess or to make some research regarding the fish migratory. So is it sufficient time to conduct the research under 3 years for migratory fishes in the river or not? From your presentation, we saw that you have an example of the fish ladder that could be implemented. Maybe it is best implemented for some of much fishes. But sometimes in Indonesia, we know there's so many species of fish that could be there will be a consideration to find the right construction of fish ladder. So do you have any references that can we suggest to our engineer in Indonesia for our mega biodiversity of fish that could be used in Indonesia? Thank you.
Thank you. They are actually wonderful questions, and they are questions that we deal with all the time as academics. The first one about the socio-economic considerations is a big one. I'll address the economics first. The engineers always want the cost to be reduced of the intervention. And there are many different ways to do this. But we always find that we will consider 4 or 5 different solutions at a site. And we will get costings for 4 or 5 different solutions at a site. And so we present the engineers with options. Then they can make the economic decision based on the cost. Now, the cost also is driven by the benefit that will derive. And so quite often there are some sites, and this is there's a project underway at the moment to prioritise sites for investment, and we are focusing on the Chitteroom catchment, is that at some sites, the cost-benefit analysis may not be good. There may only be a short section of river or no fishermen upstream, so you may not invest in a fish ladder. So sometimes it's good to prioritise which sites are most important ecologically, socially, and economically, so that you get the best value for your investment. On the second part about the best design of the fish ladder, especially in megadiverse situations, I will say as an ecologist, the best fish ladder in the world is no dam at all. So the first step, if you want to rehabilitate fisheries, you would either remove the dam or find an alternative way to store and deliver the water. And there's a lot of those options coming worldwide. But obviously, sometimes you have to build the dam. The work that Mas Dewey has been doing in Pajaya has been all about understanding the swimming ability of the fish and understanding the success of the fish going through the fish ladder. Now, that is always the first step, is once you understand how strong the fish can swim, then you can understand how you design the fish ladder to cater for that fish. And in many areas, that data does not exist. So if you want to build cheaper fishways that pass more fish, the best thing to do as an academic is do the research which defines the swimming ability of the fish and then translate that into the best design of the fish ladder. That way, we find that once you have that data, you can justify the expense because you know that the fish ladder will work. And secondly, you can use that data to make sure you pass as many fish as possible at the site. That's always going to be very difficult to pass every fish, but you can the target we have is 95% of fish. If you can pass 95% of fish, then you have an effective fishway. It's really difficult to do without the data. And that is what happened at Pajaya the first time. Without having that data, the fishway wasn't entirely suitable. Now when we build the fish ladder in the Cibareno River, we have much more information now on Indonesian fish, and we hope that will be more successful. We will learn from the Cibareno, and then the next one we build after that will be better and better again. So we apply that in what we call an adaptive management framework. We just get progressively better as we learn more and more. So as academic, research is the best thing you can do, and then provide that information to the engineers.
Thank you, Pak Lee. Is that clear, Irfan? Yeah, that's very interesting because we have to consider ecological, social, and economy. Yeah. Okay. I move to the Zoom first because there is a question with the chat from Pak Oscar. Oh, Mr. Oscar Umwan Siswem. Would you like to ask by yourself or I just read your chat?
Okay,
Pak Oscar?
You can read Ibu, no problem.
Ya?
You can read, no problem. Or bisa tanya.
Ya, boleh Pak. Silakan, boleh langsung Pak.
Ya, terima kasih. For the marine ecosystem, the main problem we have now is plastic pollution. So, and I know Australia is between the sea. So how is it mitigating and adapting on this plastic pollution? And as we know, plastic is not in the stable condition. It means it can move from one point to another one. Thank you.
Yeah. He's asking about plastic pollution. Yeah.
From a fish passage perspective, one reason the plastic pollution is bad is that it can clog the fish ladders. And if it gets into the fish ladders become ineffective. So it's really bad. And a lot of the work we do in the Mekong has so much plastic as well. I think 8 garbage trucks per day flows out of the Mekong.
Yeah, similar in Indonesia. You
similar.
can see in Poso.
Yeah, it's really bad. So, I mean, in Australia, we don't have so much a bigger plastic problem because we have a lot of regulations. If people throw plastic in the river, the police can give you a fine, and no one wants the fine from the police. Yeah. So it doesn't happen very often. Look, the biggest way we've seen that people are tackling the plastic problem is encouraging people to recycle the plastic, and we call it the circular economy. And so getting that, if you can find an economic way or economic benefit of reusing the disposable plastic, it seems to be having the best outcomes. One of the problems, though, is that a lot of the plastic, it ends up, say, in the Pacific Ocean. Yeah. Some people, has people heard of the Great Pacific Garbage Dump?
Yeah.
Yeah, and it all goes into the middle of the Pacific Ocean. Now, some of the plastic that's entering the ocean today can take up to 10 years to make its way to the center. So even if we stopped all of the plastic going into the rivers today, it will still happen for another 10 or 15 years. So addressing the source of the plastic pollution is the best one. It's really tricky. And even in Australia, we see a lot of investment from the water bottle companies or Coca-Cola. You know, Coca-Cola bottles find their way into the ocean. They are now starting to invest a lot more in plastic reduction solutions. Nets over drains to capture all the plastic before it enters the river, and physically cleaning up the rivers themselves. Yeah. It's a really big problem, a really big problem. And thank you for the question. I wish I had the answer. It's not an easy problem.
Yes.
It requires social solutions.
Social and government, I think, yeah. Okay.
I mean, the Chittarum is the big success story. The Chittarum had a really bad plastic problem, but it took a really big effort to clean the Chittarum and remove all of the plastic and stop the pollution. So the Chittarum is a good success story to prove that it can be done. But I think it took the army to help.
Yeah, yeah. We need army to stop plastic going to the river. But I think we really need this kesadaran, the warning from ourselves.
Yeah.
That's better. Oke, Pak. Sorry, Pak Oscar dari mana?
Dari Rwanda, Pak. Dari Rwanda, Ibu.
Rwanda. Oh, thank you very much. Wow.
Tapi sekarang mahasiswa PCR. S2-nya.
Okay, thank you.
Ya, sama-sama.
Okay, now we move again to this room. So, is there any question from audience here? If you want to ask in Bahasa Indonesia, please, it's okay. Yeah. Yes.
Yeah.
Oh,
Thank
okay,
you.
silakan Samuel. Yeah.
Okay, thank you for the chance to ask questions. Hello, Mr. Lee. My name is Samuel, and I'm a bachelor student in Aquatic Resources Management Department in IPB University. And my question may be an elementary question. I would like to ask you, you said that if we want to make better fishways, we should learn the fish behavior, how they swim in the river. And I haven't learned how to observe fish when I'm studying here. So could you tell me what is the effort given to learn fish behavior in swimming upstream and downstream? Thank you.
That is a really, really good question, because I didn't talk about that, did I? There's a few ways to do it. And actually, there's one, our colleagues who visited Bandung recently went to the hydraulics laboratory at Bandung. And in the hydraulic laboratory at Bandung is a model of a fish ladder. So it's a model which is the same size as a fish ladder, control the flow. And what many people do is they will put migratory fish into this flume and allow the fish to swim. Now the flume has glass windows, so you can see the fish swimming, and you is that you can build an experimental fishway. This is a small fish ladder, and you can take that into the field, and you can use actual migrating fish at site. You can control the flow through the fish ladder. This is a little better because when you are in the wild, in the river, there's many more species than you can take to a laboratory. So quite often we would do the laboratory tests to understand the maximum and minimum swimming abilities of some key important species. Then we would take the experimental fish ladder into the field where we get the data on all of the other fish. And so it's almost similar to Masdui's PhD. His experimental laboratory was per Jaya Dam. And the work that he did, and maybe you might like to answer this, Dewey would make the water fast in the fish ladder and slow in the fish ladder and deep and shallow. And he would record the responses of the fish in the fish ladder. And he has almost the first data on swimming ability of Indonesian fish in a fish ladder. And we will use that data then to build better fish ladders. I'm not sure, Mas Dewey, if you'd like to comment. In Bahasa is fine.
Yeah, Mas Dewey, please.
Hello. Thank you, Pak Lee, for the opportunity. Yeah, thank you for the question. So, what we did in Perjaya Dam, that we assessing the fishway. So they have, as Dr. Lee saw in the picture and the video, that in Perjaya Way they install a fishway, and it not based on local fish community. So they just copying from Japanese ayu fish. So in this in my study, so we assessing whether the fishway is appropriate for local fish community, and also because fisher is catching fish in the fishway, so the impact of fisher is also significantly worsening and the passing fish to upstream. So this is like Dr. Lee said that like experiment on the field. So we, in the end of the study, we found that most of a fish we collected is like a small fish, not like a ayu that can jump until 3 meters. So so we suggested that some modification for the fishway, and also some like, because most of a fisher is like catching fish within the fishway. So we did option for the local people to have another option for livelihoods. Thank you.
Thank you, Pak Dwi. So, Pak Dwi is from BRIN. He is doing PhD in CSU. And the case right just in fishway in Perjaya. So, it's a very good example. Okay, Samuel, udah terjawab? Ya. Okay. Yeah. You have more to add?
No, I was saying thank you for the question.
Oh, okay. Okay. Okay, then we have a question from the Zoom. It's from Ardiansyah. Pak Ardiansyah mau bicara langsung atau saya bacakan? P502 PSL ya? PSL.
From PSL.
Yeah.
Thank you, sir. My name is Ardiansyah. I'm from PSL, the master degree student. My question is how to make sure that an industrial business of freshwater fish can go along with the environmental sustainability assurance. Many of us know that in freshwater fish production, some of the species, it is there is no barrier on the production. It's very big production and can be affect the environmental balance. So how can we build the how can we make sure the industrial business of freshwater fish can go along with the environmental stability assurance? Many thanks before.
Okay, he is asking about how to make sure the industrial business of freshwater fish can go along with the environmental sustainable assurance. So it's about fish aquaculture, I think. Is that yet, Pak Ardiansyah?
Yes.
Okay, yeah, but aquaculture business like that. Yeah.
Yeah, I think that the way we see aquaculture affecting, particularly in reservoirs, is where aquaculture has been intensively developed. Actually, this is Professor Chris's area, and it affects the water quality. If you have the aquaculture of a high density, it can actually create high ammonia and also create excessive nutrients in there.
Yeah.
So we do find that there's a need to balance aquaculture and make sure that the water quality stays sufficient. And it may even be as simple as moving the aquaculture pens around the reservoir, so you are distributing some of the waste products. I'm not sure, Chris, if you know of any practical examples of how aquaculture has been managed, but I know that in Australia the best way to do it is make sure that you are using sustainable densities.
I would have to think much more to come up with some practical examples, but it all comes back to what you said, Lee. It is the balance of productive capacity. You've got the productive capacity from aquaculture versus the productive capacity from the lake itself, what people will call carrying capacity of the lake to support that level of aquaculture. What happens so many times, of course, you see it everywhere, is that something becomes successful, an aquaculture operation is successful, more people or more cages, and suddenly it is overproduction, much more carrying capacity, much more biological demand on the water than the water can naturally sustain. There was actually a big project here, but like in Indonesia a few years ago, on the carrying capacity of, is it Chilakang Lake or something like that? I cannot remember the name of the lake, but it was exactly what we are talking about. There was too much aquaculture in it, and all the natural fish were dying because of pollution in the lake. So there was a big study where they had to restrict the amount of cages in the lake.
Cirata. Probably
Yes.
Cirata.
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 Yeah.
Cirata is one of cascade dams of.
in West Java, and that's why I asked that question, because many of the production especially in dam area or in the freshwater area, the carry capacity is overproduction. So that is become our problem. But actually about the regulation, maybe Prof. Hedney, how about the regulation in Indonesia related with the carrying capacity of freshwater fish production?
Yeah, Umaya.
Yes,
Yeah, I invite my student to classroom to this general lecture actually, from the environmental management study program to master class come to this general lecture. That's why the student asked a question here. Right, okay. I have also one question actually, Prof. Baumgartner. You mentioned that all of freshwater fish doing migrations, yeah? And in our case in Indonesia, Irfan already explained that we have mega biodiversity in terms of aquatic. If we find out in the river, not only one species, we have 100 species, migratory species. So it is enough only for 1-2 years doing research of fish ladder, since the government project to build a dam only 2-3 years, and then we have to do research 5 years, perhaps for government it's not acceptable. So how do we cope with this situation, Professor?
Yeah, we find the same. And in that situation, you don't have enough time to get data on every fish. So in that case, you can simplify the assessment process. For designing a fish ladder, you can just focus on some of the weaker swimming fish and some of the bigger, stronger swimming fish. And then once you have catered for the biggest fish and the smallest fish, all the fish in the middle should be okay. And so sometimes you can streamline your assessment based on those observations. Now, what we will find is that in reality, after you build the fish ladder, some fish are not as good as swimming as you thought, or some fish are stronger swimmers than you thought. That's when you apply the adaptive management and learning to the next site. So as important as doing the laboratory trials on the swimming abilities of your extreme fish is doing the field studies of the fish ladders as they are constructed. So the next important step for our study is that once the fish ladder is constructed on the Cibareno River, we will assess the success of that structure, and for as many species as can ascend that structure. We're doing a study now, Arif, aren't we, on the Poso River of the existing fish ladders at Poso, and we will learn about what is successful and what is not successful. so that the next fishway that the Poso Energy designs will be better than the existing one. So it's all adaptive management. I always talk about mobile phone. And I say that, can anyone remember what a mobile phone looked like in 1995? Yeah, it was big. It was big. And a big antenna.
Yes.
And sometimes they were the big ones that were under the seat of your car in a bag, really big. And so in only 20 years, the size of a mobile phone and the technology in the phone has gone from the big one, the banana, to this. So it's the same with fish ladder technology. The fish ladders that we built in the 1990s are not as good as the fish ladders we build now. And this is because of the adaptive management process.
Okay, thank you, Pak Lee. Pak.
Yes.
Sorry, it is adaptation of the fish to the equipment or devices, or adaptation of the human to improve the technology?
It's both.
Both.
It is absolutely both. Yeah. Yeah. The technology gets better as you advance. The construction techniques get better and cheaper as you advance. But we also find too that a fish, the first time it swims up a fish ladder, can be very slow. And if the same fish goes to another fish ladder, it's twice as fast because it's already done that before. So the fish do learn how to swim better. Yeah.
Even fish learn, yeah.
Fish learning.
Yeah.
You know, everyone says a fish doesn't remember. They remember.
Nice. Okay, we still have time. Is there any question from here? Pak, dari SPL ya? SDP juga? Ayo, cocok banget. Fishway, silakan. Pakai bahasa Indonesia nggak apa-apa. Ini ada Pak Hefni, ada Pak Bambang, bisa bantu terjemahkan.
I think maybe when we build our fish ladder, a field trip for the students might be good.
Yeah,
good idea.
Should be.
To go to the fish ladder and see the fish ladder working.
Yeah, but
could be a good invitation.
The closest fishway will be Cibareno, but no, I don't know when they built it.
What would be the closest fish ladder we are designing, Arif? Closest to Bogor?
Cibareno, I think, Pak. Cibareno, because Ciulan is still unknown.
Yeah. Yeah. Yes. Yeah. And if at the Hydraulic Institute in Bandung has the fishway model, you could see the fishway model in the institute, which is much closer. Okay. Sukabumi is a long way to drive.
Oh yeah. No. Pak Arif, I remember the one from Poso Energy says that they have a prototype in Sukabumi, in Cigombong.
Physical model.
Physical model, but it's smaller, but you can imagine this one is this one. Yeah. 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 Yeah, 1 hour, about an hour.
Okay.
Okay.
Perfect.
I will ask Pak Adi and Pak Agus from Poso Energy. They are also in Zoom, Pak Arif. Probably Pak Adi or Pak Agus can join. Yeah, join, give permission or allow us to go to the what do you call the prototype? Yeah. Yeah.
I would say Poso Energy have been really good to work with.
Yeah.
Because they really want to do a better fish ladder for the fish of the Poso River. And they're really thinking hard now about getting the better outcomes for the eels. The eel problem to solve there is challenging, but Poso Energy are building a ramp for the fish to swim down. And also, I think Masvitas starts his PhD. He will be looking at options to provide upstream passage for the glass eel and the alva. So there'll be new information there to improve things. So that is really good, because once the knowledge is known, that can be applied to other hydropower sites.
Yeah.
So it's really good.
So how about the regulation in Indonesia? Perhaps in Australia it's already a must to build a fishway, How about in Indonesia? Is there any regulations set up by the Minister of Public Work to build a fishway? Is still optional or still already obligatory in Indonesia? Or?
Better,
Do you want to? Arif can answer this one. Want to use microphone for the Zoom?
Yes, this is becoming our focus at the beginning of the project. So, unlike Lao PDR, at the moment, the irrigation department, they have this regulation. Every weir dam built by irrigation will be equipped with fishway. When back in 2019, when we start the project, we do not have this regulation, but now we have this regulation based on the Presidential Decree number 1 in the year of 2023 about the mainstreaming biodiversity. So basically, for development of Indonesia to fulfilling food security and so on, building the dam, the weir, they need to protect the biodiversity, mainstreaming biodiversity. And based on this regulation, at the moment, PAECA and the Ministry of Public Works now trying to put the fishway on the criteria perencanaan or criteria of the planning. Once this criteria of the planning issued by the Ministry of Public Works as a derivative of this presidential decree, then I hope in Indonesia all the weir dam will be equipped with fishway. But then in Indonesia there are 3 players. One is the weir built by the central government, meaning like the area irrigated paddy plantation should be more than 3,000. If less than 3,000, so the authority is not the central government, it's not the Ministry of Public Works, but this is the provincial government who build it. At the moment, the West Java province, they have this provincial regulation. So this is becoming the first province in Indonesia where when some kind like a similar like public work in the central government, when they build dam or weir, they're going to be equipped with a fishway. But still, we have a problem now regarding the capacity, because they have a regulation, and when they're trying to implement the regulation, they always asking people from the water resource management what will be the best design of the fishway. So it will be good. Maybe later of this year, we are going to organize the second master class to invite more people to be educated about the fishway, how to build the fishway, so that this is going to expand.
Yeah, that's the explanation, Pak Hefni. So Pak Hefni used to work with the Ministry of Environment, yeah. So probably Pak Hefni will make suggestion and bridging with the fishway for the regulation.
Yes. As I mentioned earlier, the government of Indonesia nowadays build a lot of dams, and sometimes they don't care about this fishway. So by having this lecture, so I can urge the government to be more much stronger in dealing with aquatic biodiversity, and perhaps can be also incorporated in Ministry of Environment Regulation. When we are doing an environmental impact assessment, Professor Gardner, every project in Indonesia should be completed with the environmental impact assessment. In doing so, we have also doing research on biodiversity, either terrestrial or aquatic, and but not yet regulated yet. The obligatory of building a fishway. So in connection with the Ministry of Public Work, perhaps later on, Ministry of Environment can also adopt this regulation and put in the EIE regulation in Indonesia, because I'm the one who suggests that regulation. So, okay, good idea.
Very good. Yeah. In Indonesia, we said it's gayung bersambut. So it means it's good suggestion from one side will accept by other side goodwill, and then they are collaborate.
Yeah.
Yeah.
Okay, thank you, Maya.
It was a really interesting observation, and maybe Masdui might want to expand on this, but Masdui did some stakeholder interviews as part of his PhD. And he talked to the fisheries managers, and he talked to the irrigation engineers, and he talked to the fishing people. Yeah, and interesting that when he talked to the irrigation engineers, and please elaborate more, Dewey, the irrigation engineer said, do you ever see any fish migrating at the weir or see anything? And the irrigation engineer says, that's not my job. My job is to operate the weir and to build the weir. It's not my job to do the fish. The job of the fish is the fisheries manager's job. And that was interesting because most day of the week, the irrigation engineer is at the weir.
Yeah.
The fishery manager is not at the weir every day. And so a lot of the knowledge of the fish could be understood by the engineer. But when he did the undergraduate training, they didn't learn about fish ladders. And when they had the job, the boss didn't tell them to look for fish, only told them to worry about operate the structure. So there's an element of education or capacity building, as Pak Arif said, is we run the master classes now which teach the engineers about the fish, and the engineers teach the fisheries managers about the operations of the weir. And when they have the shared understanding, everyone understands the different perspectives, and then you have the goodwill on both sides. So sometimes it's just a small communication or education barrier that can be overcome.
Thank you, Pak Lee. Okay, do we have one more question, please, from this room or from the Zoom meeting, Zoom room? No? Okay, then. I think we have to close this lecture and give a very big thank you to Professor Lee Baumgartner to have this lecture and the discussion. Hopefully we can have more enlightenment about fishway, fish passage, and the importance of this fishway. So I hope every student here or in the Zoom probably can give make a like small notes about this lecture, and then you can pass it to Pak Muklis, because Pak Muklis cannot attend this lecture today because he have to do something else. Is that okay with you, student?
Pak Muklis is really interested in this.
Yeah.
Yeah.
Sure.
And the eels. He always talking about the eels.
Yes.
Pak Muklis is really good.
Yeah. Yeah. He's really a fish biologist.
Yeah, passionate. He's
Yes.
passionate.
Okay. So, I'm sorry. There is one message. Oh, it's for the absence. Okay, and then I would like to thank again Professor Lee Baumgartner, Professor Chris Barlow, and Dr. Christine, Caroline, sorry, to come to our study program, Aquatic Resource Management, and this lecture will surely give another view to our study program, and hopefully the faculty member that come here also can give another perspective to the lecture. Okay, that's the end. Pak Hefni, you have another? No, okay, and we'd like to close this lecture and come with the big applause to Professor Lee Baumgartner. Thank you very much and good afternoon. Okay, can we have group photo? Yeah. And thank you for the attendance from the Zoom meeting. Sorry, I forgot to mention all of you. Oh, there's Bu Yusri. Thank you, Bu Yusri. Hopefully, I can go to Palu and meet you again. And thank you for Pak Agus and Pak Adi from Poso Energy. Give regard to Ibu Irma.
Thank you Ibu Maya. Thank
Iya.
you MSP FPIK IPB. Jaya selalu.
Oh, thank you Ibu. Oh, thank you Pak Aryo. Pak Aryo is one of our lecturer. He said interesting talk, roughly, and thank you.